Hello everyone, this is Dr. E, and for today we're going to be working on answering some word problems involving ratio and proportions and its properties. Understanding notations in mathematics, especially in geometry, is important more than the operations and the theorems that we're going to be working on. It's also essential that when we are working with problems in geometry, we know how to write them to be able to make sure that we are answering word problems and construction problems correctly. And that's what we're going to be working on in these examples that we're going to be answering for our problems, wherein we're going to be using the properties of proportion and how we can modify equations similar to what we are seeing right now. We have rational equations, A over B equal to C all over D, and there are ways on how to modify these equations so that it will be a lot easier for us to work on them once we start applying it into word problems and construction problems in geometry. So we have here the first property, which is the equivalent property. So if we have A over B equal to C over D, we can take the reciprocal of those two fractions and it will remain the same value. And we're working on this to be able to modify our equation that will help us in answering some of our problems on similarity. So if we have, let's say, 2 all over 3 equal to 4 all over 6, and we need to change its composition using property number 1, we can modify this into 3 all over 2 equal to 6 all over 4, and we're not changing the values of the fraction. We are merely modifying our equation so that it will work for us in some problems that we're going to be working on in the future. And we know that they are the same because 6 times 2 is equal to 12 and 3 times 4 is also equal to 12. And if we do the same process in this fraction, 4 times 3 is also 12 and 2 times 6 is also 12. So we know that we are just modifying our fraction using this property. And for the second property, we have A over B equal to C all over D, and we're going to be using the switching the means property, wherein in this case, if we have A over B equals C all over D, we are just going to switch the values of our means, which is B and C, and we will still have the same value of our fraction. So if we're going to be using the same set of fraction, just like what we have started on example number 1, if I'm going to use property number 2 for the same fraction, 2 over 3 equal to 4 all over 6, using the means and switching the means of our fractions, we are still going to be getting the same value. So that means the denominator here and the numerator here will still the same, which is our extremes, and the means, we're going to be switching the value of those means. So this will become 2. I'm sorry, this is not 4, this is 6. So this is still going to be 2, and this is going to be 6. So what happened here is we switched our means, and we retained our extremes, and still able to produce the same fraction. So again, we know that this is 12 and this is 12, and if we multiply 6 and 2, it's still 12, and 4 and 3, it will still be 12, so they are still the same. And the last property that we can use in modifying our fraction, we have A over B equal to C all over D. By adding the denominator and the numerator and copying our original denominators, we will still produce the same equation but with modified fractions, similar to what we did on properties 1 and properties 2. So for our last example, same fraction, 2 all over 3 equals 4 all over 6. This is supposed to be 6. What's happening to property number 2? They're all the same. It is the original fraction, but we are modifying the third one. And this will remain the denominator. The numerator will still remain 2 and 4, but we are going to be adding its respective denominator to our new modified version of our fraction, and we will have our equation, and they will still be equal to each other, because if we check this, 2 and 3 is going to be 5 all over 3, and 4 plus 6 is equal to 10 all over 6. But this time, if we multiply 6 and 5, it will give us 30, and 3 and 10 will still be 30. So we modified our equation, but the value will still remain. They are the same, they are equal, and this is the property, or the third property, that we can make use of when we are working with proportions similar to the examples that we have shown. So if we have problem number 2, and problem number 2 will have 3 over x equal to 4 over y, and we're going to be representing them into 3 ways, which is the properties that we have just discussed. So by completing this work, all we need to do is to modify our original fraction, 3 all over x equal to 4 all over y. If we're going to modify it using the first property, property 1, all we need to do is to switch the denominators and the numerators. X all over 3 equal to y all over 4, and they will still be the same, and that's for property number 1, changing the reciprocal of our fraction. And for property number 2, what we can do is switch our means. So that means this will still be the original fraction, 3 over x and 4 over y. And what we are going to do is we're going to switch the value of our means, x and 4, the second diagonal. So 3 and y will remain, but x and 4 will switch. This becomes x and this becomes 4. And this is the second property of changing our fractions, so that we are modifying the original and giving an equation that is still correct. And for property number 3, we have the same fraction, just like what we did. The denominator will still be the same. The numerator will still be there, but we're going to be adding the numerator into our denominator for our modified version of property number 3. And these are all the modified version of our fraction, so that we're using the property, we're just modifying how it looks, and this is going to help us in answering similarity problems in polygons that we're going to be seeing in a little while. So let's say that we have this particular polygon, and in this polygon we have two triangles on top of each other, the bigger one and the smaller one. So in this diagram we have a proportion of x over 6 equal to y all over 7, and the ratio that we're going to modify this equation with is x over y equal to a fraction. And how are we going to modify our fraction? We can use property number 2 to be able to produce our equation in this problem. So in property number 2, all we need to do is to switch the values of our means, and we'll be able to produce the value of the proportion that is equal to what we are supposed to be producing. So that means if I have x over 6 equal to y over 7, which is our original equation, we're going to switch the 6 and the y, and by doing so, using property number 2, we're able to produce the values of the fractions that we're going to modify our equation with. So this value of the numerator will now be equal to 6, and the denominator will now be equal to 7. And this is how we use the property in modifying our fraction. Now, let's answer some problems on proportion and make use of the proper way of writing our notation correctly to be able to produce the answer that we're supposed to be working on in this example. So in this example, on a Chamber of Commerce map of Abitas Springs, 5 miles corresponds to 2 inches, and we're looking for how many miles will correspond to 7 inches. So in our given problem, we have 5 miles is to 2 inches, and we're looking for the number of miles 7 inches will correspond to. So what we need to do is just to apply the same concept on writing the ratio and proportion, and now we know that we are working on finding the value of the number of miles that will correspond to 7 inches, given that our ratio from the problem is that 5 miles corresponds to 2 inches. So in this case, we're looking for the values of x, and all we need to do now is to complete our equation. So in our first equation, 5 is to 2 can be converted into a fraction form, 5 all over 2. And if we have x to 7 in fraction form, we can write it as x all over 7. And now that we have our equation, we can use cross product to be able to solve for the values of x. So 7 multiplied to 5 all over 2 is going to be our new equation, and now that x is by itself, we'll be able to produce the value of x that we're looking for. In this case, it's 35 all over 2, and if you want to change this into decimal, half of 35 is going to be 17.5, and 17.5 is the value that we're looking for that will correspond to 7 inches using this map. So 17.5 miles corresponds to 2 inches in this problem. And with that, applying the same concept, we'll be able to answer the second problem, which is the standard dose of an antibiotic is 4 cubic centimeters for every 25 pounds. Now, if at this rate, we need to find the standard dose for a 140-pound woman, how are we going to find it? Using the notations that we have worked on ratio and proportion. So on the first statement, we are given that 4 cc or cubic centimeters for every 25 pounds of body weight is the dosage recommendation for this particular problem. Now, in our word problem, we need to find the standard dose for a 140-pound woman. So we are given the weight, and now we're looking for the cubic centimeters or dosage that we're going to administer to this weight. So using the same concept, we're going to write our equation. And to write our equation, we're just going to refer it to our first statement. 4 is to 25, which is similar to 4 to 25. And here we have blank 240 pounds, and if we're going to change it into a ratio, it's simply going to be box is to 25. So in fraction form, this can turn into 4 all over 25 equal to this proportion, which is a box all over 25. And if we want to be more algebraically or mathematical in our fraction, we can replace the box with an x. So we have 4 all over 25 equal to x all over 25. X over 140, not 25, 140. And by cross multiplication, we're going to multiply 4 and 140. 4 times 140 all over 25, and that will be the value of our x. And by just simplifying our fraction, by multiplying 4 and 120, we'll be able to find the values of x that we are looking for. And in this case, it's 560 all over 25. And that's the ratio that is going to fit this 140-pound woman for that dosage to be appropriate. So that is how we complete our word problem involving the properties of proportion and how we use notations correctly. So for your number bender challenge for the day, An NBA basketball player averages 45 baskets for every 100 attempts. Now, if he attempted 800 baskets, how many do you think will he make in this particular problem? So find out the number of baskets he will make using the proportion that is given to us. And that is your Numberbender challenge today, that you can comment down below for your answer for our work on proportion and in our lesson in the properties of proportion. So in geometry, it's important that we know how to write notations and make sure that we are able to translate verbal statements or word problems into its algebraic form, because in geometry, we need algebra to be able to answer problems involving word problems that we have just worked on. So to be more confident in working with problems involving geometry, practice will really help you understand this better. So this is Dr. E, and see you again next time. Bye.